For millions around the world, video games serve as a huge source of fun and entertainment. They are definitely a big part of my everyday life. Although many are in 2D, there are also several in 3D. Some games are built simply with a programming language. However, the one I am using is known as Source, which moves beyond text-based programming by adding textures and compiling complex models together to form one three-dimensional game. To be exact, the game I'll be explaining is Team Fortress 2. Released by Valve Software in 2007, this game's unique take on a war-themed simulator provides entertainment to people around the world. Now, we aren't talking about the game itself. We are actually going to be talking about the game with its physics engine. We'll be talking about the acceleration due to gravity by using the concepts that we've learned in physics. So without further ado, let's think outside of the orange box. In the 17th century, Isaac Newton discovered a phenomenon that he called gravity. It's the force that keeps us stuck to the ground instead of floating up into space. From this concept, scientists and mathematicians have created several experiments, tests, and equations that require the concept of gravity to function. The one that we'll discuss today is acceleration due to gravity. The acceleration of gravity is the understanding that when an object falls, instead of falling at a constant rate, it increases its speed as it falls until it reaches a constant known as terminal velocity. In this clip, we have a character falling off a 38 unit tall ledge. Of course, at the beginning of this fall, his initial velocity is 0. However, during his fall, his velocity slowly increases. In the table I have here, I count the number of units fallen after every half second for 2.5 seconds. As you can see, the concept of acceleration due to gravity is very noticeable. However, from such a low height, the character did not reach terminal velocity. The equation we use to calculate the average acceleration is v2 minus v1 divided by t2 minus t1. Our v2 is the total units traveled. In this situation, it's 38 units, subtracted by v1, which here is 0. This is all divided by the time he fell. The time that he falls is at t2, which is 2.5 seconds, subtracted by t1, which is 0 seconds. When we finally divide these numbers, we are left with our average acceleration, 15.2 units per second squared. Now that we have the acceleration, we can convert this into real-life units. The average human height is 1.65 meters. In this photo, we can tell that this character is approximately 1 1/3 units tall. By using simple algebra, we can deduce that 1 unit in this game is equal to 1.24 meters. Our final conclusion is that this game has an average acceleration due to gravity of 18.85 meters per second squared. That's almost double the real-life measurement of the acceleration due to gravity, which is 9.8 meters per second squared. So what have we learned? We have learned that video games are very unrealistic when it comes to physics. The reason? I'm not sure. Maybe the higher acceleration of gravity makes the game move faster, and it keeps its players engaged. Or maybe the programmers just aren't that concerned with reality. All I know is, despite being unrealistic in the world of physics, I still love this game. And now that I understand the gravity of gravity in video games, thank you for watching.